Hello everyone, Dr. Zia Tahir here. This video tutorial is solution of problem 2.77 of chapter 2 free vibration of single degree freedom system from Mechanical Vibrations 5th edition by S.S. Rao. Statement of the problem is a uniform circular disk is pivoted at point O as shown in figure. Find the natural frequency of the system. So you need to find natural frequency. Also find maximum frequency of system by varying the value of B. So first I'm going to show how to find natural frequency of this disk. So G I am representing here as center of mass of the disk. So let's say that the disk is being from its mean position. It is given an initial displacement. So or initial angular displacement theta, and theta is small. So sine theta is nearly equal to theta and cosine theta is nearly equal to 1. So that is its displaced condition. And for this displaced condition, I am going to apply Newton's second law of motion here to find its equation of motion, and then from equation of motion, I'll derive I'll find out its natural frequency. So the assume mass of disk is m. So the total weight of the disk is going to act vertically downward, mg, and if that angle is theta, so then that mg can be resolved into two components, one perpendicular to radius of rotation, that is mg sine theta, and the other component going in that way, it is mg cosine theta. So now this mg sine theta is responsible for any moment. So here I can apply sigma m, sum of all moments is equal to J equivalent theta double dot. So sum of moments is equal to J equivalent theta double dot, and that is the direction of motion, which is in counterclockwise, and the moment due to this mg sine theta is clockwise, and mg sine theta is responsible for moment, but that mg cosine theta, because it is passing through center of rotation, so it will not contributing any moment. And that mg sine theta, so it is in clockwise direction, opposite to the direction of motion, so it is taken as negative. So minus mg sine theta times by radius of rotation, and radius of rotation from O to G is B, and is equal to J equivalent. So for disk now, for disk, so the formula for moment of inertia of disk having mass m and radius about its center of mass G is half mr squared. But this disk is not rotating about its center of mass, but it is rotating about O. The distance of O and G is B, and in this case, it will be Jg, which is half mr square plus md squared. So radius of rotation in this case is here is A. So equivalent is going to be half. I am assuming m as mass of disk, and radius of rotation of the disk, or radius of disk, is A squared here, and plus m into d, and d here is distance between center of mass and radius of rotation, which is b, so it is b squared into theta double dot. Now assuming sine theta is nearly equal to theta, so here I can replace sine theta with theta, so it is minus mg theta b is equal to m half a squared plus b squared is equal to theta double dot. So I can cancel that m with m, so then I'll get here as g theta b is equal to half a squared plus b squared into theta double dot, and then I can multiply both sides with 2. So to get rid of this denominator with a squared, so it is 2 b theta is equal to a squared plus 2b squared into theta double dot, or then it will become a squared plus 2b squared theta double dot and plus 2gb into theta equal to 0. So that is equation of motion. Now for torsional vibration, if that is the equation of motion in standard form, J equivalent theta double dot plus KT theta equal to 0. So then the natural frequency will be whatever is the coefficient of theta divided by whatever is the coefficient of theta double dot. So in this case, the natural frequency can be written as 2GB over a squared plus 2b squared. So that is the natural frequency of the system. So the first part of the question was to find natural natural frequency of the system. So that is the natural frequency omega n. That is the natural frequency of the system. For next part of the question, find maximum frequency of system by varying the value of b. So it's mean that we are trying to develop now a relationship between frequency and b. So for getting the maximum value, we need to first derivative find derivative of omega n with respect to b, and then second order derivative, and then we'll see that after setting first order derivative equal to 0, so what are the possible values of b, and then putting those values in the second order derivative to find the maximum value. So now uh, we need to find first order derivative of omega n with respect to b. So next, first order derivative of d omega n over db. So by using power rule of differentiation, power at the start half, and then uh, take away 1 from uh, half minus 1. So it will become minus half, and then on the term in the bracket using quotient rule. So then a square plus 2b as it is into derivative of the numerator 2g minus the numerator as it is, and the derivative of the denominator. So a square is 0, and for 2b square is 4b over square of the denominator. And then I can, after simplifying uh, numerator here and then making that power positive by flipping it. So it is 2a square g plus 4b square g minus 8bg square. And then after simplifying it, 4b square g minus 8b square g. So it will become minus 4b square g, and here a squared plus 2b squared half is going to cancel with square, so leaving that a squared plus 2b squared raised by 3 over 2. And then further simplifying it and taking 2g common factor from uh, numerator here, so it is 2g, and within the brackets a squared minus 2b squared, and in the numerator it is 4gb into a square plus 2b square raised power 3 by 2, and then 2g is going to cancel with that, and finally you will get a square minus 2b squared is equal to 2b into a square plus 2b square raised power 3 over 2. And to get the maximum value you need to find stationary point, and the stationary point you can find by setting d omega n over db equal to 0. So when you're going to set that equal to 0, so you will have a squared minus 2b squared over the numerator 2b into a squared plus 2b squared 3 over 2 is equal to 0, and from here you will get a squared minus 2b squared is equal to 0, or you will get a squared is equal to 2b squared. So after setting a squared minus 2b squared equal to 0, so you will get a squared is equal to b squared and b squared is equal to a squared over 2. And then taking square root, you will get b as plus minus a over 2. Now to identify those, that you will have two values of b. So one is b equal a over root 2 with positive sign, and the other one is b minus a over root 2. So these two values now will get, and now we need to find second order derivative and check that for which value second order derivative is uh, negative. But if I try to substitute before that, if I try to substitute those values back in the natural frequency, so if I'm going to substitute that natural frequency value of B in the natural frequency formula, so what I can get if B is negative, so that is not possible. So when B, we are going to put it negative, so negative of root is not possible. So when we are going to get that omega n at B is equal to minus A over root 2, so that will become a complex number or imaginary. So it's mean that this value of B is not a valid value. Okay, so we don't have to need a second order derivative, so just only this is the only valid value. So that is only valid value of B. Okay, so this value of B will give a real value of omega n. Now, by omega n expression, we have just derived it. So now I'm going to substitute value of B in that expression for omega n. So B is plus A over root 2. So it will become 2g into A over root 2, and in the denominator A square plus 2, and B square is will become A square over 2. And then after simplifying in the denominator, I'll get 2a, and then after further simplifying 2ag is 2 root 2a, and 2 is going to cancel with 2, and a is going to cancel with square of a, and finally I'll get that natural frequency at is equal to g is equal to root 2a. So now in this case the value of b, if it is they're going to change it, so the maximum, the value of b for which the natural frequency is maximum, that is a over root 2. And let's say if I am going to set that b equals 0, so b equals 0 means that the o will become the at the center of mass. So in that case, when b is equal to 0, this leads to omega n equal to 0. So it's mean that when b is equal to 0, using that expression, natural frequency is 0. So then the natural frequency omega n, the maximum value of it is for g is equal to root 2a under the radical. So that is the maximum uh, frequency of system by varying the value of b. So when b is equal to 0, natural frequency is 0, and when b is equal to a over root 2, natural frequency maximum is g over root 2a. So that is the solution of problem 27, 2.77. So thank you very much for watching.